Hello everyone, welcome to this video. And in this video, we are going to discuss about entity relationship model to relational model mapping. So ER model, which is a conceptual model, in order to implement it, we have to first convert it into a relational model. And to do this, we have to follow the ER to relational mapping algorithm. So let me start off with the help of an example. Let's see how this algorithm will work. So as you can see, we have a ER diagram here. It has regular entities. It has relationships of 1:1, 1:n types. It has weak entities. It has ternary relationships. So let's see how we can convert this or how we can map this ER model to the relational model. So to start off, the first thing that we will do is we will first map the regular entities. So when I say regular entities, what I mean is this. As you can see here, ship here is a regular entity. Ship type is a regular entity. Similarly, state, country, sea, ocean, each of these are regular entities. So for regular entities, what we shall do is for each regular entity, we will create one relation each. So let's say for ship, we'll create one relation. And in this relation, what we will put, we will keep the attributes of ship. Like say for ship, we have the attributes S name and owner. So in the ship relation, we will have S name and owner as attributes. Next, we will create another relation for ship type. So let's create another relation for ship type. So ship type. So ship type has attributes type, tonnage, and hull. So we'll create these attributes. And something I forgot to mention earlier is that in the ship relation, the primary key was S name. So in the relation also, primary key will be S name. Similarly, for ship type, the primary key was type. So here also we'll underline the primary key type. So now let us look at the next regular entity, which is state, country. So for state, country, we will create one attribute, one relation. Let's call it state, country. And here we shall put name and continent. And name is underlined because name is the primary key. Similarly, for the entity sea, ocean, lake, we'll create one relation. So as you can see here, it has got only one attribute. So I will just make this little smaller. So I have name. Okay. So I have completed converting the relations ship, ship type, state, country, and sea, ocean. So these entities, we have already converted it into relations. So for regular entity types, for each regular entity, we will create one relation, and that relation will contain all the attributes of that regular entity from the ER model. And the primary key that was underlined in the ER model will also be the primary key of the relation. Now, once these are done, let us look at the next, that is the weak entities. So as you can see, the weak entities in the ER model, these are represented by the double underline, double bordered relations. So as you double bordered entities. So as you can see, ship movement, port, then port visit. Each of these are the weak entities. And in the weak entities, as you know from the ER model, it is always related with some strong entity. So for ship movement, the ship entity is the parent entity. Similarly, for port and the weak relationship is this ship at port, and corresponding to this, the strong entity is again ship. Similarly, for port visit, ship at port is the weak relationship, and it is associated again with ship. So here we shall take all the weak entities and we shall convert them into relations. So to do that, let us start with the first one, which is ship movement. So let us put it here, one for ship movement. So for ship movement, what do we have? The attributes that we have are latitude, longitude. Then we have a composite attribute, timestamp. So we'll put latitude, longitude. Latitude. Let me put it as LONGT, longitude. And since timestamp is the kind of the primary key, is the key here, timestamp, and it is a composite attribute with the simple attributes, date and time. So instead of putting timestamp, we'll put the composite attributes, that is date and time. The simple attributes, date and time. So date and time. Now, since ship movement is a weak entity and it is associated with the parent entity ship, so we will take the primary key of ship and put it in this new relation. So the primary key of ship was S name. So we will include S name here as the foreign key. And what will be the primary key of this relation? So the primary key will be the combination of the primary key of the parent relation and the partial key of the weak entity. So date time was the partial key. And with that, we combine S name, which was the primary key of the owner relation, which was ship. So for ship movement, latitude, longitude, date, time, and S name are the attributes. Let us move to the next weak entity. Next weak entity is port visit. So for port visit, we shall create port visit, we shall create another relation, and here the attributes are start date and end date. So we shall put these two here. Start date and end date. Okay, and the partial key is your start date. Now this is associated with the owner entity again, with this owner entity as ship. So we shall again put the primary key of ship, which is S name, here. So the primary key of this relation will be the partial key and the primary key of the owner. So start date and S name. So let's look at the next one. Next is port. So port is associated, is a weak entity, and it is associated with which one? It is associated with, sorry, I think earlier I mentioned that port is the weak entity and it is associated with ship. Yes, it is associated with ship also, but it is also associated with state and country. So let's see. State, sorry, this is port. Port consists of port name, and it is in a weak relation here in, and it is associated with state country. So we'll put P name P name, and the primary key of state country was name, so I'll put name. And together these two would be the primary key. Similarly, here now we have all these weak entities we have handled. Now let us move on to the relationships. So relationships, we have 1:n, 1:n. All of these are, most of these are 1:n. So we'll consider first the binary relations. That is the relation between two entities only. So history here is a 1:n relation. All of these type here is to 1:n. Most of these are 1:n relation, except for ship at port, which is a ternary relation. So all these binary relations we'll consider first. So in a 1:n relation, if you have a 1:n relationship in your ER model, then what we can do is we can take the primary key of the relation which is on the one side. So here I have, on the one side of this history, I have S name. So what we will do, we will take the primary key which is on the one side and put it in the relation which is on the N side, which is ship movement. So let me repeat, for 1:n relationship, take the primary key of the relation which is on the one side, in this case ship, and put it in the relation which is on the N side, which is ship movement. So the ship name, that is S name, should go into ship movement. So ship movement, S name should appear. Now already S name is already appeared because it was a weak entity. Ship movement was a weak entity. So from the weak entity, S name is already gone. So we don't need to do anything else. So now we'll move to the next 1:n relation, which is, let's take this one, type. Okay, so this is a regular relation. It's not a weak entity or weak relationship. So on the one side, we have ship type. So we'll take the type attribute, which is the primary key of ship type, and put it in the ship relation. So in the ship relation, we'll put the type. So in ship relation here, already we have created the relation. So we'll put type. So type here is a foreign key, and it refers to the type here in the ship type relation. So this 1:n relation is also taken care of. Now let us look at some more. Let's look at home port. Home port also, this is a 1:n relation. So the one on the one side, that is our port, okay, we will take the primary key of port and put it in ship. So take the primary key of port and put it in ship. So where is ship? Ship is here, and here we will put the primary key of port, which is P name. So P name here will be the foreign key in ship. So second relation is also done. Now let us look at the next one, which is, let's say this, that is in port in state country. So already this is already handled actually because it's a weak relationship. So again, let us say one part, this is on the one side, that means name should be taken and put in port. So let's see whether port already contains name. So port already contains name. So this is done. Here you need, if just one moment before any confusion takes place, here you can see in these two relations, name here refers to state country, refers to your state country, and here in sea, ocean, lake also you have an attribute called name. So just that there is no confusion, let's just call this sea name. Let us call this sea name, okay, state country name. So in that case, this will be sea name, just to avoid any confusion. So this will be sea name, continent name or country name. Okay, so this is already done. So we don't need to do anything more here. So 1:n relation in taken care of. Now let us look at this one. That is here on. So what do we do? The thing on the one side, the primary key of the relation in one side, that is sea lake or sea ocean lake, will take name and put it in port. So now you can see in port, we will also put name. So name here will be the foreign key. So name here refers to sea ocean lake relation. So all our 1:n relations are taken care of, right? So we are left with now, all we are left with is this ternary relation, which is ship at port. So this is a ternary relation because it is a relationship between three entities: ship and port visit. Okay, so for a ternary relation, what do we do? The mapping algorithm says that you create a new relation. One of the option is to create a new relation and put in it all the primary keys of all the participating relations or the participating entities. So create a new relationship at port, ship at port, and put in it the primary keys of all this relations. So ship, put the primary key of ship. So ship primary key is S name. Okay. Primary key of port is P name, C name. So put P name, C name. Then we have port visit. So port visit is primary key of port visit is start date, S name. Start date and S name. S name is already appearing here. So we'll not give this again. Okay, we will not give this again. So all these attributes we have added. Okay, and together all of these will be the primary key of this new relation. So let me repeat again. For a ternary relation, take the primary key of all the participating entities in the relations from the relations, and then put them together in in a new relation. Also, if the particular this ternary relation has some attributes of its own, suppose it had an attribute of its own, then you add these attributes also to the new relation. Now, since this ship at port doesn't have any attribute of its own, so we will keep it as this. So now, as you can see, we have covered all types of components of this ER model. We have covered the regular entities. Okay, all the regular entities, we have a relation for them. For all the weak entities, also we have relations. Okay, as you can see, ship type and state country, sea, lake, ocean. Okay, all these regular entities. Then ship movement, we have ship movement was a weak entity, we have a relation for it. Port visit, we have a relation for it. For port, we have a relation for it. Okay, then for the ternary relation, we have ship at port, we have one new relation for it. So we have covered all aspects of this particular ER model, and we have converted it into a into the relational model. So this is the relational schema for our relational model. Now here, another point to be noted is that the primary keys have to be underlined. At the same time, there are some of these attributes are foreign keys. So from the foreign key, you will have to draw a line referring to the primary key that it is referring to. Like here, type in ship is referring to ship type in ship type. So we have to draw a line. Here, P name is referring to the port name. Okay, so we have to draw a line It might look a little messy, but don't worry, you'll be able to do this. So port name will come here, P name. Then similarly, what do we have here? Here, S name is referring to ship name. So S name is a foreign key, which is referring to ship name. So you draw a line here. Similarly, here also S name referring to, please don't mind my curly writings. Okay, it's I don't have very steady hands. So like this. Similarly, this name here, this is C name. C name refers to C name here refers to country name, I think. Yes, this one. And this name here refers to sea lake, sea ocean lake. And lastly, each of this. So this will be to ship. Okay, I will not draw it. This will be to port. This will be to state country. And this start date would be to your port visit. So finally, you have your relational schema. So this is your relational schema for your ER diagram. This is the ER model. So this is how you can convert an ER model to the relational model. We will discuss the full algorithm in a different video.